Okay, guys, let's look through this question and see how we're supposed to attempt this. First and foremost, they say that figure 8.1 shows a vertical current carrying wire passing through a card at point X, right? So I have a current that's passing through here. They ask you to sketch the pattern of the magnetic field produced, right, by the current. And the detail of your sketch should suggest the variation of the strength of the field. First and foremost, if I have current flowing through a wire, what happens is there will be its own magnetic field, right? And I'm supposed to use my right hand grip rule, remember? Using the right hand grip rule, since the current is going down, I'm supposed to point downwards. And if the current is pointing downwards, it means to say that based on my fingers, my four fingers are rotating in the clockwise direction, right? Meaning to say the magnetic field produced will be in the clockwise direction as well. Okay, first and foremost, you all need to know that when you draw the magnetic field, you need to draw at least 3 circles. This is actually a requirement from the mark scheme. And each circle should be further and further away from the source. This indicates that it is actually going to be weaker and weaker in terms of the strength. And once you have the 3 circles and bigger circle, right, all you need to do is just draw the arrows to indicate that the magnetic field is in the clockwise direction, and you've gotten your 3 marks here. Easy, straightforward. Then for question B, using your knowledge of investigating the magnetic field around a bar magnet, suggest an experiment or experiments to confirm that you have drawn the correct pattern and also direction. This can be no other than whatever we learned here, right? The iron filing and the compass. Once again, the iron filing, you sprinkle it to determine the pattern of the magnetic field, whereas the compass, you align to the pattern to determine the direction here, right? So having said that, if you bothered to refer to your notes, you would have gotten the exact answer, but some of you guys don't even bother. Sprinkle Sprinkle iron filing on place sprinkle iron filing onto the paper and gently tap the bottom of the paper to allow iron filing to fall to magnetic field. This determines the pattern of the magnetic field. Next, place compasses around the pattern of the magnetic field to determine the direction of the magnetic field. Bang! Literally everything you read on top. So I don't want to dwell too much here. This next question is an interesting question, though. They say that a second current carrying wire is inserted vertically through Y here. So just why there is now a force acting on the wire of X. And if you think about it, if today I have another wire, let's change it into a different color. I've got a different wire that is shooting downwards here right now. It itself will produce its own magnetic field, right? When it produces its own magnetic field, you see, they have interaction here, 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 and here, right? Because the magnetic fields are interacting right now, then naturally it will either have a attraction force or repulsion force, right? But you don't need to know whether it's attracting or repelling. No need. You just need to know that the magnetic field lines are interacting, and thus it produces a force, an attraction force or a repulsion force, right? So you're going to say something like the wire in Y produces its own magnetic field, which interacts with the magnetic field from wire X. Is it Y and X? Yeah. Okay. And finally, this last question here, they say right now that the wire Y is moved from, sorry, the wire at Y is moved to Z, carrying the same current. Take the appropriate box to indicate whether the force on the wire at X is now smaller, greater, or same. And if you think about it very logically, the answer is obviously going to be smaller. Why? Because right now I'm moving further away. If I'm moving further away, it means to say the magnetic field from the new wire is going to have less interaction with the magnetic field from the old wire. And because of that, logically speaking, it cannot be anything besides smaller. Okay? If you look at this question here, right, it says that it shows a positively charged plastic rod, right? This thing here, and a metal block resting on an insulator and a wire connected to the earth. First and foremost, initially, before anything happens, this thing is neutrally charged, right? And because it is neutrally charged, it means to say by right, the amount of positive charges must be equal to the amount of negative charges, right? Because if the distribution is different, then it's no longer neutrally charged, right? If this was the distribution, it will be positively charged, right? Whereas if this was the distribution, it will be negatively charged, right? The first thing is you must assume that this is neutrally charged because it's not stated to be charged. And because of that, you must draw the negative charges on top and the positive charges at the bottom simply because the negative charges are being attracted upwards by this positively charged rod. Anyways, your answer is you're supposed to draw equal amount of positive and negative charges, whereas the negative charges are more on top. So if you drew 5 here, then you drew 5 at the bottom. That's the first one. Right now, this second diagram, it says that the earth wire is held against the metal rod. Right now, like I've mentioned, this earth wire that acts as a bridge of electrons allow for the flow up or the flow down of negative charges, right? It allows the flow up or flow down of the negative charges. My question to you all is, will the negative charges flow up or will it flow down? This is the positive rod, right? If it's a positive rod by right, it should attract the negative charges upwards, right? So at the end of the day, what you're expected to draw is you're expected to draw more negative charges on top and less positive charges at the bottom, indicating that the flow of negative charges came up here. Makes sense more, guys? Okay, guys, last question of the day. Yeah, if you look at this question here, once again, it's a repetition, right? Once again, they ask you in terms of electrons, why copper is a conductor and nylon is an insulator. This one is 3 marks, right? Anytime something is a conductor, it's because copper has 3 moving electrons, 1 mark. Nylon does not have 3 moving electrons, 2nd mark. Easy, straightforward. Then after that, you're asked, describe how the negatively charged rod may be used to induce a positive charge on the copper sphere. I want this thing that is negatively charged to induce positive charge in this copper sphere here. Your idea should be revolving around charge by induction, guys. First and foremost, connect a earth wire to this copper sphere. Then bring this negatively charged rod close to the copper sphere. Remove the wire first, then remove the rod, and you have induced it with positive charges. Okay, so first and foremost, bring the negatively charged rod close to the copper spheres. Connect the copper sphere with earth wire. Remove the earth wire first, then remove the charge rod. Easy. Okay, the whole idea revolves around charge by induction only. If you don't want to write what's it called the earth wire here, right? You can even say that just touch it. If you touch it, you will act as the earth wire for this copper sphere. And the final question here, it must be going outwards. Need to draw at least 4, guys. And look at the mark scheme. At least 4 equally spaced radial lines from the surface. And it must be pointing outwards. For me, I'll usually draw 6 up.